Hello friends, in this video lecture we will be demonstrating assay of trimethoprim in Co-trimaxazole tablet. So we have already studied various methods of multi-component analysis using UV spectroscopy. One of the important method is assay after the solvent extraction. So today we will be using Co-trimaxazole tablet, and this tablet contains two drugs. So one is a trimethoprim, another one is a sulfamethaxosaur. So in each tablet, this is a label claim. So each tablet contains trimethoprim of 80 mg and sulfamethaxosaur of 400 mg. So our aim is only to analyze or find out the concentration of trimethoprim. So starting with the principle of experiment. So this is assay after solvent extraction method. It is a multi-component method of analysis because it has two components in a formulation. So when absorbance of interfering substance is very high, then or the total absorbance cannot be calculated. For example, here our analyte is trimethoprim. In addition to trimethoprim, we have the interfering substance, that is sulfamethaxosaur, which is also UV active, and it will have a very good absorbance at lambda max of trimethoprim. So in such case, the total absorbance is not only because of trimethoprim, but it is also because of the interfering substance here, that is a sulfamethaxosaur. Okay. So what we need to do, when other methods are not applicable or useful, we have to go for isolation of these interfering substance, or we have to isolate the analyte of our interest. Okay. So one of the method to isolate the analyte is liquid extraction, or it is also called as solvent extraction. Okay. So we can remove or isolate the analyte of interest by various ways, and one of the way is by changing the pH of the solution. So we know the basic concept is when we have acidic pH. So in acidic pH, if you have any basic drug, so basic drug will get ionized in acidic pH. So ionization will happen, and once the drug are getting ionized, what will happen? Its aqueous solubility is increased. Okay. So we can use another phase or different solvent which is non-aqueous, and we can separate the drug into two phases. So these are the structures of the drugs which we are going to analyze. So this is a structure of trimethoprim. Okay. So it has a pyrimidine ring in the structure, and the other part is shown in the figure. So this is a trimethoprim. Now trimethoprim is basic in nature, and sulfamethaxosaur, this sulfamethaxosaur is acidic in nature. Okay. It is acidic in nature. So what will happen if I take these drugs? So Co-trimaxazole tablet contains both of these drugs. Okay. So if I am dissolving this in an basic pH, who will get ionized? Obviously the acidic drug is getting ionized. So if acidic drug is getting ionized in basic pH, this drug's solubility is greater in aqueous phase. Okay. And this drug will remain unionized. Okay, because it is basic in nature and we have provided the basic pH. So in basic pH it will remain unionized. Okay. Or vice versa, if you take the acidic pH, then trimethoprim, which is basic in nature, that will get ionized, and this will remain unionized. Okay. Now we will see the procedure how to perform this experiment. So we have to first weigh powder equivalent to 50 mg of trimethoprim. Okay. So we have to find out the equivalent weight, which you are already familiar. So you have to take 20 tablets weight, then find out the average weight of each tablet, and from that you can find out with the label claim the powder containing 50 mg of trimethoprim. Okay. So once you do that, then we have to take one separating funnel. Now in the separating funnel you can take 0.1 molar NaOH. So this you can take 30 ml of 0.1 molar NaOH. Now to this you can add your powdered tablet weight, which is containing 50 mg of trimethoprim. Okay, so you can pour that trimethoprim powder, which is also containing an sulfamethaxosaur, into this. So what will happen? Because of the alkaline pH, which drug will get ionized? Obviously the acidic drug will get ionized in the alkaline pH. Okay, so here acidic drug is sulfamethaxosaur and trimethoprim is basic drug. So basic drug trimethoprim will remain unionized, okay, and sulfamethaxosaur is getting ionized at this alkaline pH and it will increase its solubility in the aqueous medium. Then what we have to do? So this is the first step. Then second is we have to take the chloroform layer. So you have to take 50 ml of chloroform and add to the same separating funnel. So what will happen? It will form a two phases, because chloroform is organic and this is aqueous. Then we have to put the stopper and shake the separating funnel, and after shaking you have to wait so that it will separate into a two layers. Now remember, chloroform is more denser, so it will remain on the bottom. Okay, it will go at the bottom layer. Okay, and the aqueous layer, that will remain on the top. So what is happening here? Because we have increased the solubility of sulfamethaxosaur into an aqueous medium, it will remain in the upper layer, and the trimethoprim, because it is unionized, it will go into a chloroform layer. Okay, so we can take out the bottom layer into a beaker. Okay, so this we can name it as a first batch of extraction, or it is a first fraction. So this first fraction containing a good amount of trimethoprim and very little amount of sulfamethaxosaur. Okay, now this phase is called as a raffinate phase, and this phase is called as a extractant phase. So this is a raffinate phase, the phase which is being to be extracted, and extractant phase, the phase which is being used to carry out the extraction. Now what we can do? We have same raffinate phase. Now we are going to extract with fresh chloroform or fresh extractant phase. So we can see here, now we have here the same raffinate phase, that is aqueous phase. Now again I am adding 50 ml of fresh chloroform. So again you can shake this flask, then wait for two phases, and then once it separate, then you have to take out the bottom layer. Okay, that is a second fraction. Okay, in a second beaker or same beaker you can do it. Then you have to repeat this same procedure with same raffinate phase. So every time you have to take fresh chloroform, okay, 50 ml, and then you can do this third step and fourth step. So that means 4 batches of extraction with fresh chloroform as a extractant phase, which is used to separate the trimethoprim from this aqueous raffinate phase. Okay, now once we do that, then you can collect or combine all these 4 fractions of chloroform and add in fresh separating funnel, and then you can wash those combined extract with 0.1 molar NaOH. Okay, and the volume is 10 ml. Okay, now once you do that, then next is you have to combine those 4 extracts after washing, and then you can put in a separating funnel. Now the drug is in the chloroform, but this chloroform is an organic layer, and this we cannot use for recording the absorbance. So we have to take back our drug into a aqueous phase. So we know trimethoprim is basic in nature, so we are using now acidic pH, that is 1 molar acetic acid. So take 50 ml of 1 molar acetic acid and then do the extraction of this. So what will happen? The trimethoprim, which is basic in nature, will get ionized in acidic pH, and its solubility will increase now in the aqueous medium. So it will shift from chloroform to the acetic acid layer. Okay, so we can take out this chloroform extract now, which becomes now raffinate phase, and then take out this acetic acid layer. Okay, so the green one is acetic acid layer, and then with same chloroform again we can repeat the procedure. So second, third and fourth. So 4 batches of extraction you can carry out with same chloroform as a raffinate phase using fresh 1 molar acetic acid of 50 ml every time. Okay, so we have now 4 extract of acetic acid layer which we can combine and we can wash with 5 ml of chloroform. Okay, so this we can do 2 times. This we can do 2 times. Okay, so 2 times we can wash the combined extract with 5 ml of chloroform, and then you can take this into a 250 ml volumetric flask and dilute up to 250 ml with 1 molar acetic acid. Okay, so once you do the dilution, you can mix it properly, and then from this you have to pipette out exactly 10 ml to a 100 ml volumetric flask. Okay, then add 10 ml of 1 molar acetic acid and then dilute the final volume up to 100 ml with distilled water. Okay, and then we have to measure the absorbance at its lambda max of trimethoprim, that is 271, and A1% 1 centimeter is 204. We have taken an equivalent weight of powder tablet which contains 50 mg of trimethoprim. So what we are going to do, we are going to extract or separate trimethoprim from sulfamethaxosaur. So we have taken this separating funnel and we have checked it for leakage. Now what we have to do, first we have to measure 30 ml of 0.1 molar NaOH and we have to transfer that NaOH into the separating funnel. Okay, so I have measured already 30 ml of 0.1 molar NaOH and I am transferring this into a separating funnel. After this, we can transfer the powdered tablet which we have weighed as per the equivalent weight, and carefully we have to transfer this into this solution. Okay, then we can shake this little bit. Now keep in mind, this is not going to solubilize completely because it contains both the drugs, that is trimethoprim and sulfamethaxosaur. Now what we are doing here, we know trimethoprim is basic in nature, so basic drugs are getting ionized in acidic pH and acidic drugs are getting ionized in basic pH. So in this case sulfamethaxosaur is acidic drug, so what will happen, the sulfamethaxosaur will get ionized in alkaline pH and its solubility in aqueous media will get increased. On the other hand, the solubility of trimethoprim, as it remains unionized, it will not go into a aqueous phase. Okay, so what we are going to do now, we are going to add the chloroform. So chloroform is an organic solvent, so we will take 50 ml of chloroform in the measuring cylinder. So I have measured now 50 ml of chloroform and I am going to transfer this 50 ml of chloroform into this. Now if you observe carefully what is happening, though chloroform is organic solvent, it is settling at the bottom and it is taking the aqueous phase into the upper part. So this is unusual. This happens because of the density of the chloroform. So chloroform is more denser, it has density roughly around 1.4 which is greater than water. So chloroform will settle at the bottom and aqueous phase will come on the top. Then we have to do the extraction. So we have to cork here and then we can take out the separating funnel. Then first we have to remove this and then slowly we have to shake this flask. Okay, so you have to keep in mind, when we are shaking the separating funnel, the pressure should be released because it has the organic layer and it will build up the pressure and there is a chance of getting explosion. So we have to shake this vigorously. So what is happening? The sulfamethaxosaur has greater aqueous solubility, so it will remain in the aqueous phase, and the trimethoprim will shift into an organic phase. So after vigorous shaking, we can close the cork and then we can put on the stand. Then we have to wait so that it will separate into a biphasic system or two layers. So here we can see the bottom is the chloroform layer and the upper part is the aqueous layer or the NaOH layer. So once it settles down, so once you observe a clear demarcation of two phases, then we can separate the chloroform layer. Okay, so this chloroform layer is nothing but the extractant phase, and the aqueous layer is nothing but the raffinate phase. So raffinate phase is a phase from which we extract our components, and this is the extractant phase, the phase which is being used to carry out the extraction. Okay, so what I am going to do now, I am carefully separating the bottom layer of chloroform. So this is my first batch of extraction. So here what we have done, we have isolated maximum amount of trimethoprim into a chloroform layer. So this I will name it as 1 and I will keep it aside. Now after this I am going to take in the measuring cylinder 50 ml. And then we are going to add here. So again we have to repeat the procedure. Then remove the cork, otherwise it will not settle into two phases, and then you have to wait for some time. Okay, now it has settled down. So you can collect this second extractant phase of chloroform in a separating funnel, in a separate beaker, or you can take it in a same where you have taken the first extract. So I am going to take in the same beaker. Okay, so two portions of chloroform as an extractant phase we have extracted with fresh chloroform using the same raffinate phase or the aqueous phase. Now this is a third batch. Again I am taking 50 ml of chloroform and I will add it again. Okay, so I will again repeat the extraction. I am closing this cork and then again keeping here to settle down. Okay, so it has settled down. So we will take out the third batch of this extraction. Okay, so I have collected now 3 fractions with the same raffinate phase. So what we are doing, by multiple batches of fresh extractant phase, we are trying to separate maximum amount of trimethoprim into a chloroform layer. Now this is the last one. Again I will take 50 ml of chloroform. And I am repeating the procedure. Okay, so it has separated. So these are the 4 fractions of chloroform which we have used to extract the trimethoprim from this NaOH phase or aqueous phase. Now this is containing maximum amount of sulfamethaxosaur. Okay, so this we can discard. So I am keeping this separately. I will discard this. So this separating funnel we can keep it aside. Now I will be using fresh separating funnel, and with this fresh separating funnel, now what I am going to do, I am going to add this 200 ml of chloroform which I have used for extraction into this separating funnel. So I will carefully transfer this 200 ml into fresh separating funnel. So this has little amount of sulfamethaxosaur. So what we are going to do, we are going to wash this chloroform with 0.1 molar NaOH. Okay, so we will take 10 ml of 0.1 molar NaOH, so that if it has any sulfamethaxosaur, it can be washed. So I am adding 10 ml of 0.1 molar NaOH. So we have to shake this. So this is called as washing to remove any sulfamethaxosaur which has come into an chloroform layer. Okay, so allow it to settle down. So again keep in mind the bottom is a chloroform layer and the upper is an aqueous layer. Okay, so once it's settled down, again in the same beaker we can collect this chloroform extract. So this is our NaOH which we have used for washing, so that can be discarded. Now Again same chloroform layer I am washing with fresh NaOH. So that means we have to wash the chloroform 2 times with the NaOH, and NaOH volume is 10 ml. Again we can shake this. Remove this cork and it will separate into 2 layers. And then we can take out the chloroform layer, which we have washed now with 2 portions of 0.1 molar NaOH. So this is our chloroform layer, and the washing of NaOH we can take out. So I will take little amount of chloroform and just I will rinse this separating funnel for better accuracy. So this is done. Now what we have to do now? Now we have separated the trimethoprim into a chloroform layer, but this is an organic phase. So this phase we cannot use for recording an absorbance in UV spectrophotometer. Now we are going to take back our trimethoprim, which is now present in this organic layer, into an aqueous layer. Okay, so we know that trimethoprim is a basic drug, so it will get ionized in acidic pH. So we are going to now extract this trimethoprim from chloroform with the help of aqueous acidic solution. Okay, so we have 1 molar acetic acid. So this is 1 molar acetic acid. Now we have to extract the trimethoprim by ionization with the separating funnel with this 1 molar acetic acid solution. So again we can take 50 ml of 1 molar acetic acid. Okay, so I have taken 50 ml of 1 molar acetic acid, which I am transferring here. So again we should remember the acetic acid, which is in aqueous form, it is on the top, and the chloroform, though it is organic, because of the higher density it is in the bottom. So we can do the extraction. Again you have to shake this. So what is happening, because of acidic pH, basic trimethoprim is getting ionized and it is shifting into an aqueous layer like this. So we have to allow it to settle down, so it will take some time. Okay, so I am going to take here this bottom layer, that is chloroform, from which we are separating our trimethoprim. Okay, so this is the first batch of extraction with aqueous acidic pH. So this is our acetic acid layer. So I will take in a fresh beaker. So this is my first batch of extraction with the acetic acid. Okay, now this I will keep it aside and I will pour back this chloroform layer because I have to extract it again. So again I need 1 molar acetic acid of 50 ml. Okay. Then we have to repeat this. So this is the second batch. Okay, so we can take out the bottom chloroform layer. Then you can take this second batch of 1 molar acetic acid extract into a fresh beaker, or you can take it in the same beaker where you have taken the first batch of extract. Okay, now we are going for third batch. So again we need 50 ml of 1 molar acetic acid. Okay, so this is third batch. I am collecting this acetic acid layer in the same beaker, and now the last batch of extraction. So again take 50 ml of 1 molar acetic acid, and extract it. Okay, so it has separated. So we can take out this chloroform layer. So with 4 batches we have extracted or isolated maximum amount of this trimethoprim into an acetic acid layer. Okay, so fourth layer I am keeping inside the separating funnel itself, and the previous 3 layers which I have collected I am going to transfer in the separating funnel. So in other words, I have combined all these 4 extract of acetic acid layer into a separating funnel. Now like earlier we have given washing to chloroform layer with 0.1 molar NaOH. Exactly same way, now we are going to wash this acetic acid layer with the chloroform. So if at all any sulfamethaxosaur is there in this layer, which is very negligible, that will shift into an chloroform layer. Okay, so I will take 5 ml of chloroform. Okay, so this is 5 ml of chloroform. So we are washing this. So here it is quite easy because chloroform is settling down, so we can take out only that layer. So we will shake. Okay, so we can take out this chloroform layer. Now we have to again wash with chloroform layer 5 ml. So 2 times washing is required so that maximum sulfamethaxosaur can be removed from this layer. Okay, so it is settling down. We will wait for some time. Okay, so it has settled down. So I am again taking out the chloroform layer or the washing layer, which we can discard it. Okay, so now our extraction is over. Now this is an acetic acid layer which contains the maximum amount of trimethoprim which we have isolated. Now we can take out this in a fresh beaker, and then we need to dilute this. So we are going to dilute in 250 ml volumetric flask, and this dilution is made with again 1 molar acetic acid. Okay. So this is done. I will keep it aside. Now this separate volumetric flask we will transfer into a volumetric flask. So this is roughly 200 ml which we are going to transfer now. Okay. Now dilute up to 250 ml with 1 molar acetic acid. So you may add some acetic acid in this same beaker and just rinse this and then transfer into this flask and adjust the level. So some more acetic acid is required. So carefully we can adjust the meniscus. Okay, so meniscus is adjusted. We can mix this for a while and then okay. So next dilution will be in 100 ml volumetric flask. So this is 100 ml volumetric flask. Now what we need to do, we need to pipette out 10 ml of this solution which we have diluted. So I have taken 10 ml pipette and I am going to pipette out . So we will adjust to 0 and then we will pipette out this to 100 ml volumetric flask. Now we have to add 10 ml of 1 molar acetic acid . Okay, so this is 10 ml 1 molar acetic acid, so we can add that into this, and then remaining we have to add the distilled water. Okay, this is distilled water. So we will adjust the meniscus with this distilled water. Okay, so this is our final dilution. So this dilution we can take, and with help of appropriate blank solution we can record the absorbance of this solution at its lambda max, which is 271 nanometer, and a 1% 1 centimeter is given, that is 204. Once you get the absorbance, we can do the calculations. So this is how we can calculate the equivalent weight. So you all know that. Then here in this case the equivalent weight is 331.25 milligrams, and the absorbance what we got for the diluted solution is 0.4122. So with the help of Beer's-Lambert's law, we know A is equal to ABC, where A is absorbance, then small a is a absorptivity, B is a path length, and C is a concentration. Okay, so we can substitute the values here. So this is absorbance and this is a absorptivity. Path length in our instrument is 1 centimeter, and then we can find out the C, that is a concentration. Okay, so remember, whatever answer you get after solving this equation, that will be in grams per 100 ml. Okay, now we have to convert that into gram per ml. So you can divide this by 100, you will get gram per ml, that is 2.0205 multiplied by 10 raised to minus 5, or you can convert it into a milligram. Okay, so in terms of milligram it is 0.0202 milligram per ml. Then we have to use the dilution factor, because this concentration what we got is in the diluted solution, but we want how much is present in the tablet. So we have to use a dilution factor. So we have diluted the entire extract into a 250 ml, and then from 250 ml we took 10 ml and again diluted to 10 ml. So 10 times another dilution. So 250 multiplied by 10, it will be 2500 times we have diluted the original sample. So we can multiply this value with this dilution factor. So we will be getting 50.5 mg per ml. Okay, so therefore we can say 340 mg of tablet powder, which is a equivalent weight. So this is nothing but a equivalent weight what we have taken. So this mg of tablet powder contains 50.5 mg of trimethoprim. Therefore we know what is the average weight of one tablet, which we have find out from this weight of 20 tablets. So 530 mg of tablet powder contains x mg of trimethoprim. Okay, so we can solve that, and what we will be getting here, it is 78.72 mg. Okay, 78.72 mg. So that is our final concentration in a particular tablet. Okay, so we can convert that into a percentage, because we are doing assay here. So we will take, so let's say 80 mg is a label claim. So if 80 mg we are getting, it will be 100%, and practically we got 78.72 mg. So that will be how much percent? So we can solve that, and the answer here it will be 98.40% W by V. Okay, so we can write the result. The percentage purity of trimethoprim in a given sample of Co-trimaxazole tablet is found to be 98.40% W by V of stated amount of trimethoprim. Okay, thank you.